We'll walk you through how to estimate the independent and paired sample t-test and also an f-test for variances. So the data that we're working with right here is test score data. Again, this is textbook data, so don't put a whole lot of weight into the actual result. Just focus on the method that we're going to use here. And the t-test that we're going to do, the first t-test we're going to look at is going to be across male and female. So if you notice, I have the data. We have gender, race, and then test scores for reading, writing, math, science, and social studies. And we have two groups of data for males and females. So we have females over here in columns A through G, and we have males in columns I through O. So the first thing we want to do, again, this isn't a necessary step, but it helps us at least look at the problem and make some educated guess on what we think the outcome would be, is we want to compare reading scores across males and females. So I want to compare the reading score to females to the reading score for males, and the writing scores across male and female, math scores, science scores, and social studies scores. So this first t-test that we're going to estimate will be an independent sample t-test, because we're assuming the test scores for females were drawn randomly and independently from the test scores for males. So just to get a quick look at the averages, we're going to do the average for females and the average for males. We're going to do the variances as well, because we are going to test the variances, that the variances are equal as well. So to get the reading average for females, this is going to be average. We want to do this on column C. And the average for males will be the average on column K. So that's the average reading score for females, the average reading score for males. Since these are in the same order as these headings right here, I can just drag this over. And now I have the reading scores, writing scores, math scores, science scores, and social studies scores for males and females. And so notice what's happening here. So that's the average for males. This is the average for females, average for males, just making sure everything's lining up. And if you look across this, we can see that there's very little variation across test scores for females. And there's very little variation across test scores for males. But when we start looking between males and females, we do see some differences. So the reading scores are quite similar. Females, the average writing score for females is higher, about 5 points higher than it is for males. Math scores are quite similar. Males do slightly better on the science test than females, and then the social studies scores are slightly higher for females than they are for males. But we want to test to see if these differences are statistically significant. So the null hypothesis is going to be that the females and male scores are the same. So we're going to work under the assumption that there's one distribution for test scores, and males and females both follow that distribution. So the null hypothesis assumes that the two means are the same. The alternative is that they're different, that they have two different means. So when we test this hypothesis, we want to use the t-test function. So this is the null, means are the same, alternative means are different. We don't have to compute a test statistic or a critical value or anything here. All we have to do is estimate the p-value. So we use the t-test function. So t.test. Array 1 will be the column of reading scores for females. Column 2 will be the column, or array 2 will be the column of reading scores for males, k colon k. We always do a two-tailed test. Because the null hypothesis has equal to, we can reject the null hypothesis two ways. We can reject it if females are significantly higher than males, or if females are significantly lower than males. So there's two ways to reject it. So it's a two-tailed test. And for type, we want to do type equals 3. So this assumes that the variance for female, that the variances are different for males and females. There's no reason to assume they're the same, so just always do option 3 for this t-test. I hit enter, and this is the p-value. So remember from the notes that we're working under 95% confidence, and we reject the null hypothesis if the p-value is less than alpha. So if confidence is 95%, alpha is 0.05. So our p-value here of 0.46 is greater than the p-value, is greater than alpha of 0.05, so we would fail to reject the null hypothesis. So if we drag this over, notice what this is going to do. That will test the writing columns. This one's testing the math columns. This one's testing the science columns. And this one's testing the social studies columns. The p-value for writing is 0. It's rounded to 0. If we give ourselves more decimal places, it's not exactly 0, but it's 0 to 2 decimal places. So this is telling us that we reject the null hypothesis that the writing scores are the same for males and females, in favor of the alternative that they are different. So in this case, we would conclude the writing scores are statistically different for males and females. We failed to reject the null hypothesis that the math scores are the same. At 95% confidence, we failed to reject that the science scores are the same. If we chose 90% confidence, alpha would have been 0.1, and we would reject the null hypothesis. So we reject the null hypothesis that the science scores are equal with 90% confidence, but we fail to reject that null hypothesis at 95% confidence. And then for social studies, we also failed to reject the null hypothesis. And notice that's somewhat consistent with what we observe up here. The writing scores were the most different, and that's where we rejected. The science scores were had the next highest difference, but we failed to reject at 95%. And when we look at the variances, maybe that will give us some information about why. So that is the t-test for independent samples. So the next thing we want to do here is do the f-test. So we want to test if the variances are the same. So just so we can get an idea of what we might expect to see here, we're going to look at the variances for females and males. So we're going to do the var.s c:/c. That'll give us the variance for females. And var.s on k:/k will give us the variance for reading scores for males. And we can drag this over. If you get these little dashed lines right here, you just highlight those columns, double click between two of them. It'll expand it so you can see everything. And we can see that the variances are the most different for writing scores and science scores, a little bit for social studies scores. But this f-test will determine whether or not they are statistically different with 95% confidence. So if you're testing variances, the null hypothesis is that the variances are the same. The alternative hypothesis is that the variances are different. So we do this using an f-test. So we're going to do f.test array 1 c:/c for reading for females. Array 2 column k, that's the reading score for males. There are no other options here. The f-test actually doesn't have one tail versus a two tail. It's all one option here. There are no additional options. So just enter the columns, hit enter. So your p-value is 0.66, so that's a fail to reject because it's greater than the 0.05. 0.02, that's a reject. Since the p-value for that test is less than alpha, and alpha is our significance level for 95% confidence, we reject the null hypothesis. The variances are the same and conclude that they are different. For writing scores, math scores, that's a fail to reject. Again, this would be a reject at 90% confidence, but a fail to reject at 95 because that p-value is less than 0.1, which is what you'd get with 90% confidence, but it's greater than 0.05, which is what we have with 95% confidence, and then that's also a fail to reject. So just looking at this data, we can conclude with 95% confidence that the writing scores and the variance in writing scores are statistically different for males and females. At 95% confidence, we failed to reject all of the other all the other categories: reading, math, science, and social studies. We failed to reject the null hypothesis that the means are the same, and we failed to reject the null hypothesis that the variances are the same. So that's how we work with independent samples with a t-test and an f-test. On this next tab down here at the bottom, paired, this is where we can do a paired sample t-test. So what we're thinking about with a paired sample t-test is we're going to compare reading, writing, math, and science, reading, writing, math, science, and social studies scores for the same individual. So notice over here, we had a sample of females and a sample of males. The order didn't matter. We could sort these columns any way you want them. It doesn't matter. Or sort the rows any way you want within a column. It doesn't matter. For paired, notice one row represents one person. So person 1 is female, Hispanic, low socioeconomic status, in a public school, in a vocational program. And these are the reading, writing, math, science, and social studies scores for this one person. So if we want to test whether or not reading scores and writing scores are statistically different, we have to take into account the possibility that there's correlation between reading and writing scores. Since each row represents a single person, their reading, writing, math, science, and social studies scores could all be correlated with one another. So we have to account for that when we do the t-test. So just to take a quick look at the descriptive statistics, for the reading scores, we want the average of column G, standard deviation, G colon G. And now we can look at the average scores across the different categories. And notice there's not a lot of variation. That the average reading score, writing score, math score, science score, these are all pretty close to each other. So it's going to be very, very unlikely that we reject the null hypothesis that they're the same. So when we do this, we actually have to do separate t-test. If we want to test reading versus writing, reading versus math, reading versus science, reading versus social studies, we have to do a test for these two, a test for these two, a test for these two, and a test for these two. So you can see how the problem gets fairly large when you have multiple categories, because we have 5 plus 4 plus 3 plus 2 plus 1 test that we can actually conduct here. So there is a more general form of this test called ANOVA, which is called analysis of variance. And the null hypothesis there would be that all the scores are the same against the alternative that at least one score is different. So the way I'm going to do this here is not the way you would do it. It's not 100% correct, but if you just want to compare two columns at a time, this is what you would do. But if you just want to know, are any of the scores different, we can actually get that much faster using analysis of variance. But that's not something that we cover in this course. So the first test we want to cover is that the reading score, the null hypothesis that the reading score is equal to the writing score. So this is going to be a t-test. So t.test on column G for reading, column H for writing. It's still a two-tailed test, but now we're going to do option 1. We're going to use the paired option, and that allows for correlation between the reading score and writing score. And to no one's surprise, we fail to reject. The means are way too close together, and the standard deviations are too large for us to ever reject the null hypothesis that those two things are different. I mean, to reject the null hypothesis that they are the same and conclude that they're different. So we fail to reject that the reading scores equal the writing scores. If we do this again on reading versus math, we're going to look at column G versus column H. Two tails type 1. Again, fail to reject. The p-values, oops, I'm sorry, I did the exact same test. This should be column I, not column H. So even less evidence that these two are different. Again, they're closer together, so we would expect the p-value to be higher there. Reading versus science, T dot test, G against J. Oh, I'm sorry, I forgot the two-tail type 1, 5.54, fail to reject. And then the reading versus social studies, G against K, two-tail type 1, 0.79, again, failed to reject the null hypothesis. So this wasn't a very interesting example, but it gives you an idea on what the process actually looks like. So you don't have to calculate the average and standard deviations first. You can go straight to those that t-test. But if you look at the averages, it gives you some sense of what you think, what you might find. And then you can see if the results are consistent with what you expected or not. So that's how we do a t-test for independent samples, an f-test for independent samples, and then a paired t-test.